Hello, today I want to talk about uh, what I did today in about Unix regex, regular expressions, context-free grammars, and other things. So I will just give a summary first about what I did. So first, we proved that regular expressions are not regular. We showed that XML and HTML, if we have a finite number of tags, is a context-free grammar. And we explained why having an infinite number of tags wouldn't be a context-free grammar. I won't explain it again because it's already in the document, so I will go to the next point. So, what is the difference between regular expressions and context-free grammars? Context-free language. So, the main similarity between them is that both of them kind of generate the string, all the strings in the language. But the main difference is that regular expressions only allow three kinds of operations. So we only have union, concatenation, and unary operations. This is equivalent to a finite automata, like NFA or DFA. Context-free grammars allow us to make non-deterministic options in the rules and have nesting and recursive rules, which are both not allowed in regular expressions. The computational power is equivalent to a push-down automata, and the main thing about push-down automata is that it has infinite stack, infinite memory in form of a stack. So let's talk about why we need a context-free grammar to be able to match this HTML. So to understand why, I will give a very basic example. Let's move all the different tags. Let's say we have only one type of tag. So something like this. Okay, and then let's assign a word for each of the two tags, the opening and closing tags, W and N, and then the string becomes W bar N and N bar N. And now we can immediately see why this string can't be in the regular language, because in the regular language we don't have we have a very finite number of states, so we can't read n states, arbitrary number of states, and then count how many number of states are after it. This is a thing that is only possible in push-down automata because we have the stack, but we can't really do it in regular expressions. This is a basic example to show why we can do it. Another thing is that nesting requires us to check if the opening tag is the same as the closing tag, which comes to the same problem. We don't have any memory in regular expressions because it's identical to finite automata. So having no memory means that if we read a tag, we can't later check if we read that tag. So let's go to the next point. So how is this related to language design? So since we know that we were able to convert HTML regular expression, Unix regular expression to context-free grammar, we know that there is an equivalent push-down automata, right? So if we take this push-down automata and give it the code, we will be able to check if this code is of correct syntax. So for example, if we take this push-down automata and put it in a browser, we will be able to see if the website code is valid or not. I think the main thing I learned from this is that XML is not a context-free language because in XML we are allowed to give any tag any name. So technically we have an infinite number of tags, which we already discussed. We can't have in a context-free language because we can't put an infinite number of rows. How can we use this for parsing? I'm not really an expert on this, but my main intuition is that we can take the pushdown automata, and instead of just validating the input, after it reads an input, it gives us an output. And this output can be machine code or any kind of command structure. So a compiler reading the code, it will first interpret the code to machine language, and then at the end of interpretation it will give us a binary output, which will be runnable by a machine. So this way we can transform human readable programming language to a machine readable language. Matching pairs is usually very useful in programming languages, because usually any expression has a beginning and an ending. So for example, in any C-based language, you start with curly brackets and end with curly brackets, and functions begin with the same term, have brackets, some arguments, curly brackets, and so on. So being able to match these structures would help us create the machine language. And that's all. Thank you for watching, and thank you for your time. Bye bye.